SPT test, standard penetration test, is a destructive test to the ground, and it is standardized by IS code 2131 1986 and also ISTM 1586. This procedure following through that diving in when as per the equipment, the driving standard spill barrel sampler is dimension minimum 160 and can to extend up to 762 So it will set at the bottom of the boring, and then it is penetrated by 63.5 kg driving mass or hammer, which is free fall from a height of 760 So when it is free fall on the SPT rod, it will it will penetrate into the ground, and also this sampler will be penetrated into the ground. So it's will contracted a spacing 1.5 meter into the ground or at required depth. Mm, Here, when the filter or SPT rod is penetrated into the ground, the first the sampler are the last to 150 distance and counted and as a SPT value or N value. And first for first one 50 distance is known as a seated at or for seated value, but it is not counted as a SPT value. And next one or next 300 here, next 300 right side is the figure. Here is next 300 is blows we counted as a SPT value, but first 150 as known as a seated on the undisturbed soil. If there have not any first I have not any 450 penetrate, only penetrating 300, so we have to count it first to 150 and blows. Here it can refusal. When refusal, if the 150 increment and the blows is greater than 50 num 50 knots, so it will be refusal. If the for an increment of the 300, and so it is conducted by 100 blows, so it will be 100 blows or greater than, so it will be refusal. Or to hammer, here one here about when the hammer is free falling from at distance to 760 height, so it will create on it will create energy on the SPT rod or sampler, and then it will penetrate into the ground. So here on the here E is equal to half mb square, or and here V is equal to root over 2 gh. So we can measure the, we know the weight, and also we can calculate the velocity, and then we can measure the energy, how many energy per blows have apply on the SPT rod. So here you can see this the 745 475 joule apply on the SPT rod or to penetrate the sampler. So and another things by researcher Kovacs and Solomon, that's found that they are found that actual input driving energy, the sampler produce the penetration range from about 30 to 80%. So it cannot apply 100% of the theoretical value. So it is accounting as a percentage of theoretical value, so in practical field. So here ranging in another researcher Riggs et al. Here 70 to 100% and found that of the energy of the theoretical value. So here standard value is one in 70% and is accounted that as per standard SPT in value.
मैं सुभाष नवादा बोल रहा हूँ और मैं आईआईटी भुवनेश्वर में हूँ, एमटेक कोर्स कर रहा हूँ जियो टेक्निकल इंजीनियर। तो आज आईआईटी भुवनेश्वर का कैंपस के अंदर एक एसपीटी टेस्टिंग चल रहा है। दिखाऊंगा आज कैसे वो कंडक्ट हो रहा है और यहाँ पे कैसे कर रहे हैं। हेलो, ये हम आईआईटी का कैंपस का अंदर ही एक एसपीटी टेस्टिंग का सेटअप है और यहाँ पे शायद कोई सुपर स्ट्रक्चर और कोई हेवी स्ट्रक्चर तैयार होने वाला है। इसके लिए एसपीटी मशीन इधर ग्राउंड इन्वेस्टिगेशन करने के लिए आए हैं। तो यहाँ ग्राउंड इन्वेस्टिगेशन ज़रूरी है कोई भी सुपर स्ट्रक्चर के लिए, क्योंकि पहले ग्राउंड का एनवायरमेंटल, ग्राउंड का बिहेवियर, ग्राउंड का प्रॉपर्टीज़ निकालना ज़रूरी है, तब डिज़ाइन कर सकते हैं और कितना हम लोग सुपर स्ट्रक्चर कैसे फाउंडेशन कर सकते हैं। तो यहाँ पे देख सकते हैं ये पूरा एसपीटी स्टैंडर्ड पेनिट्रेशन टेस्ट का पूरा सेटअप। So here, as per standard code, the SPT barrel, spilled sampler and UDS undisturbed sampler is present, also with attach the SPT rod with different depth. And here this is the hammer, the auto trip hammer, which we have connected with SPT rod. So here also another weight for collecting the undisturbed soil, and it is also free fall while collecting the undisturbed soil. So we can see that with this sampler will attach with the cutting edge. And this hammer have the 63.5 kilo mass, and it is auto trip, and it will free fall the 760 mm automatically, but it will connected with the rope. And this is the same speed sampler, it is the 460 mm here the tripod is fit at the point of the bore hole, and bore hole is created 150 mm, and SPT tube will conduct into the bore hole and sample will collected it from the hole. After attaching with the spilled barrel and with this rod, and it is when I reached the 4 meter have conducted as per depth, and after that the 4 meter its sample will collected through the spilled barrel and SPT will conducted. So after as per required depth, so different type of length of SPT rod with attached, and then the hammer will be attached. So we and this rod is placed into the borehole vertically, and thus hammer is connected with the rope through the machine or motor or for falling. Here the hammer is attaching with the connecting rod, and also marking by chalk the 150 mm for counting the SPT value for increasing every 150 mm depth. So you can see that after fixing it vertically, the borehole also filled with the line material or bentonite. It be for preventing the any collapse into the soil, and also have the placed the casing in at the top of the ground on for the SPTs will be do vertically. So here the hammering will done, and blowing in for 150 semi will not counted it for it is the seated value. After 150 semi it will be connecting. Here the hammering is free fall from 760 auto tripping. There's only pulling the hammer, but hammer is falling automatically. There's some spring connected. So hammer and this rod or spill pull sampler is driving into the ground, and so they are counting the another person is counting the how many blows was for last 300 driving or penetration. And so after penetrating the 450 of the SPT rod, the remove the hammer, and then in the sampler will remove from the bore. Here and is hammer is put the energy on the this field put sampler or rod, so it will penetrate into the ground, and it will the sampler will collect a sample from this from the ground, and so this SPT test will conduct every 1.5 meter depth, but it is penetrating in 460 then it will was up to or bore up to 1.5 meter, then in SPT will conduct an again. Here the 4 meter SPT rod is removing from the borehole, and here we can see the spilled sampler spilled spoon sampler here with the cutting edge, and it has collected some sample, and it will be detach as from the rod, and also detach the cutting edge as and this on this the sampler are is as per our ice code, and also is metal and its dimension, and should be follow as per ice code. So and during the setup of the SPT equipment, so we have to follow the ice code, or otherwise it will destroy of the equipment, and or distressing of the equipment, so it will not give the proper value of the SPT, or sample will not come collecting the sample. So after here the person is collecting removing the spilled pool sampler. This sampler is a tube type, so core type or tube type. From removing the it's spilled, the two spilled is there, and collecting their soil sample from this spill sampler are here. They are collecting, and so we can see the brown type of soil. It's some part of the sampler. So after this this is the disturbed soil sample, because spill pulled this disturbed into the ground. So this sample will not give proper the parameter of the strength. And this sample will collected thoroughly mix, and it will put out into the polythene bag. But we have to alert the about the moisture during the sample. Here we can see this the about the borehole 5 rig number 2 date and SPT number 2. So first at the depth 4 meter, the first 159 blows, the second 150 mm increase the 17 blows, and third 150 mm 30 blows, or the last two for 47 blows. And also the describe the soil sample as a hard red wise, the brown moist medium plastic moram soil. Okay, and we can see the how sample collecting in the put into the poly is a in a polythene bag. And also can see the another sample we have collected up to 4 meter brownness. And here we can see the the one the company, the consultancy private limited, the put the sample with the tag here, which borehole, which the depth, and from where, what the date, what the remarks, and what the specific remarks. So have to, and it will be sent to the lab. It will tested into the lab. So we can see it. And it will the pack of the demoisture or packaging. Okay, if want to get the properties value of the soil, or otherwise the sample will disturb through the SPT, so we have to conduct or collecting the sample, the UDS or undisturbed soil sampler, through the undisturbed soil sampler tube cutter, or with the attach of the rod, or and here the collar or casing is fixing on the borehole, to prevent the collapse of the material into the borehole. And here undisturbed soil sample will be collected in from the borehole. We can see that the at first the through the Selby tube, or another core cutter, which is the one attached with the valve here, to reach the desired depth, or reach the required depth after 1.5 meter depth every each depth. And so one core cutter or Selby tube is fixing on into the borehole, and then cutting up to the required or desired depth. Here blowing and the slurry will provided into the borehole, and this the soil cutting and washing on the ground. We can see this person is up and down the weight on this tube, or cutting tube. And here the cutting material I'll remove from this valve, and again it will put into the borehole to get to reach the required depth. Here the undisturbed soil sample also fixed with the rod, and it will attach with the some weight to driving into the soil into the ground. And here it is also connected with the motor through the rope of the person is fall up and down, or falling into the borehole, all the UDS core cutter and for to collect the sample from the borehole. Or for undisturbed soil, is it we can testing the consolidation test or triaxial test into the lab. So there and density test, cohesion test, and angle of sharing resistance. So we can collect. Here they are pushing because they want to collect the undisturbed soil sample, and it is to drive into the ground. Here they remove the barrel of the undisturbed soil sampler. So after removing that, it should be remembered that every time the sampler will be clean in, or also observe the cutting edge, it is disturbing or not disturbed or distressing. Otherwise the sample will not collect properly. So here if it is the in the rock, so their diamond cutter will be used, and here it is the cohesive sandy soil. So they are using the only the cell cutter. Here this is a cell undisturbed soil sampler barrel, and it will be removed from the rod through the wrench. And also after removing the undisturbed soil sample, it will sample will collected from the core of the barrel. So here the cutting after cutting edge removing, the barrel will place in at a place. And but you also remember that this barrel will be placed without any disturbance and with vibration. Okay. They are removing the loose particle of the cutting edge. And then and you can see here there are some valve in on the top of the barrel. So for collecting the sample, into the sample will put pushing into the barrel. Then again they are fixing the collar in casing, and also cutting the up to required depth. After again the 1.5 meter depth, they will collect the sample. Okay. And here they collected the sample and increased the depth. Another sample or barrel is removed from the borehole, and sample is will be taken. And so we'll see the how sample will collected from the barrel. Here removing first the top bottom of the barrel, and then it will compacted and measuring the hot depth of the recover or sample the full length of the barrel, and how many depth length of the sample. So this recover percentage will mention is, into the data sheet. And also collecting the 5.5 meter depth, and whole sample with the barrel will go to the lab without any disturbance. It will put in.
So after collecting the field SPT n value, it will corrected it will be corrected because the energy is not applied 100% as per researcher. So here n dash 70 is the standard blows count. So how can it is measured? The n dash 70 is equal to C sub n into field SPT n value, and then other correction as a hammer efficiency neta 1 correction, and n2 and neta 2 is equal to rod length correction, neta 3 is sample correction, and neta 4 is a borehole diameter connection. If the this four correction is varying, so this n dash 70 value will be varying. So it is depend on the field test equipment or condition. And another things, CN overburden pressure is a overburden correction. Here the researcher Leo and Whitman 1986 uh, the he had created this formula that Cn is equal to 95.76 by atmospheric pressure P dash 0 uh, uh, over. So here is this formula we can use to calculate this n dash 70 value, standard blow count. And then, and another things, there are another correction for fine sand and silt soil. These are saturated, so it will be corrected and as per Tarjagi and peak. And so if greater than is n value is greater than 15, so it must be correction for dilation effect. So because strain the will dilation effect, the strain will increase of the silty or sandy material by negative pore pressure. So n dash value will reduce after this calculation. So here for dilatance correction, and this formula will be used. And then overburden correction, it is granular soil. If the driving is or is going up to required depth or desired depth, and it is much height, so we have to apply the correction for overburden pressure. Here the Murthy he used this for some empirical formula for overburden correction, and if you get greater than 25 kilopascal, so this empirical formula you can use. And another Leo Heitman mm, also we follow the this formula for overburden correction. And then we will see another correction is mm, for hammer. Here if you choose the as per donut hammer or safety, it is trip system or rope and pulley system. So it will be energy ratio will be applied. So it is not 100%, it will be take some ratio, and this ratio will be follow this formula. So this ratio, oh, and if the take US United States and an auto trip, this no, this is auto trip. So United States 80 to 100%. So if you ER value is 80%, if you take, so after that we'll calculate the standard blows at 70% energy. So 70% energies will, it will be value is 1.14. So here neta 1 and have to calculate. Then if rod length correction neta 2, if greater than 10 meter rod length, so correction factor is 1. If the 6 to 10 meter, so correction factor or it is reducing the n value. Okay, if it is sampler correction, if the sample is collecting through sampler without liner, so correction factor is 1. If they use the liner into the sampler, so or as a sand in dense sand, for dense sand clay 8.8 it and loose sand clay 0.9 correction factor. N is too high, so n base value n is too high with liner. And another borehole diameter where penetrating will driving in. So borehole diameter is 60 to 120 mm, so it is its correction factor is 1. And if it is increased, the correction factor will be increased. So n is too small when there is an oversized hole. And the next correction factor, if energy ratio is increased, the close count it will be decreased. Uh, if the energy ratio 45 give SPT value 20, so their energy ratio subjected to 90, so will give the SPT value 10. So after research that the standard value has taken and that is 70 energy ratio 70. So any SPT value with any energy ratio we have to convert to 70 E70 or energy 70 energy ratio of 70. So then calculated the standard n value. Here energy ratio and blows count is should be a constant for any soil, and have the energy ratio 45 have SPT value 20, so we can convert into 70 energy ratio, so n value will be follow this formula, following this formula. So here we can see the n value is 13 for 70 energy ratio. And then we'll see the next, after getting the corrected SPT n value, we'll put in a chart, and then we'll see the if which n value is required for our construction. And so here are we can see that as per researcher, we know that the smallest n value in the boring, we have to take the smallest n value. If have any particular strata, so have different n value, so we have to take average. And how many distance we have to take the n value, SPT value or n value. If it is a spade footing, so it about the 1/2 footing wide above of the base, and add to depth of about 2 b of 2 b, or that the width of the footing, so twice time width of the footing below the base up to. So here is equal to b above plus and 2b plus so this depth we have to take the SPT value to take average for design. Here follow this n average is equal to summation and SPT value into different depth as per depth and by the summation of different depth. So we have to follow, not following this. If it is a pile foundation, so the blows count in for any strata unless simple average. It will take simple average. Okay, it will not take in the arithmetic average. For spade footing, it is take arithmetic average, and pile footing, it is take simple average. It is noted and remind it when we will design for any foundation. So, and another things in that the average corrected n70s can be computed for from average field measure in value and strata. An individual corrected n70 can be computed and then average it. So at first we can average the n70 n70 and then average, or otherwise first collected individual n70 and then can average. So both can follow through the as according to researcher. And then after taking the corrected after designing the corrected n value, so we have some empirical formula by which is provided by which is research by some researcher as Mehrov 1997 give the how can the determine the relative density through the SPT value and as per depth as per trace of the ground at a desired depth, so we can see this empirical value here this formula for relative density. Okay, so n60 the energy ratio n60 taken, and then the as per depth can and take the effective overburden and also the atmospheric pressure are then put here and can determine the relative density. Also we can find the mm, angle of internal friction and of the soil through this relative density value. Here formula is there. Granular soil with the fine sand more than 5% silt. So we can follow this. And if it is the granular soil with the fine sand less than 5% silt, so we can follow the 30 plus 0.15 relative density. So, and another thing we can determine the unconfined compressive strength, and as per Bowl 1996, the confined compression QU is equal to K and corrected KPA. And we can also determine the underlying shear strength of the clay. If the ground is have clay, soft clay, so we can determine that for Cu is equal to K on coefficient and to N60. So here K is equal to 3.5 to 6.5 kilonewton meter square. Average value we can take the 4.4 kilonewton per meter square. And also we can determine the modulus of elasticity, which proposed by Kulhoe and Maine in 1990. So here this empirical formula we can use. So here alpha is varies as per consolidation and sand condition, soil condition. Okay, or otherwise we can after that the n value corrected n value, so some correlation is here by Peak et al. such a peak at around 1974, or we can see this varying the um, corrected n value 0 to 4, 4 to 10. It is also, if SPT value is increasing, the soil getting from loose to soil is from loose to dense. So here it is increasing the soil condition also, from loose to dense, and relative density also from 0 to 85%, and fixation angle also increasing. So all are increasing as per increasing the SPT value. Here if it is SPT is conducted on clay, so here we can see that the clay, if increasing the SPT n value, so it's a under sustain also increasing. In, if it is greater than and 10 and 16, and so it can be 100 to 200 in kilopascal. It is hard to deform by squeezing as condition of the soil. So we can follow this chart. uh, and other things we will see the another properties of the soil, another parameter of the soil through laboratory test after collecting sample from site. Okay, after collecting the data and sample from site, we will make the report. So how do you make the report for SPT test? Here the ground level with surface level, so you have to measure ground surface level through or auto level or total station, and then type of boring, which type of borehole has created, and by which following method. And another, the diameter of the hole, and the inclination, it is a vertical borehole reference, the change the location of the borehole, and here also borehole, and the we have to measure the groundwater table from the ground level L here. So because we have to corrected to measure the corrected SPT value. Here how prepare this chart. So at first, the serial number is created at 1 2 3 4. How it is created? As it is created as per depth. 1.5 meter depth varies, and the 1.53 4.5, every 1.5 meter depth it is serial number is taken, accounted, and then the varies as per depth, as per varies the soil layer, soil strata. So here different strata is can see that different strata can see that at here, and also uh, different strata is marked by different scratch. Here also we have to present in this chart, uh, and every depth, every change of the layer. So here have some identification name is a clay sandy, as such is a classification of the soil. So type of soil is of the strata. So up to 1.5 meter clay sand, then it is changed to silt clay with medium compressive, and then silt clay with low compressive. If- and it is the and then change also, the soil strata is changed, and then also changed up to here 6 to 12 meter. The 6 meter is the same soil, the silt and clay with low compressibility. So we have to represent that. And then also color. During the sampling the collect, we had to notice that which color we can found the at the field as per depth. So here brown color, all soil or sample is bound, and when every depth collecting sample through which process it is the undisturbed soil sample, it is the disturbed soil sample. um, if it is the if it disturbs some sample, or is it a standard penetration spill sampler. So we have to notice that, we have to present that. So if it is if we want to get the proper parameter, and through laboratory test we have to collect it the undisturbed or UDDS sample. And also we can if it is the not collecting, or it will be disturbed if you collecting through the undisturbed soil sampler. So we will conduct the SPT in this portion. So SPT is the spilled barrel will be collect the sample. And here first 150 blows value. Oh, okay, n value. Oh, it will not counted. It will be not counted. Next, second 150 in 15 semi penetration or driving in value is this. And the third one 150 or 15 semi penetration or driving in value, driving blows value is counted as 10, 15, 21, 28. So which I have to need, or which I have to must counted accounted. So here last two and third second and third 15 semi, second and third 15 semi and value we have to account it. Here this last test 10 and 7, and it is getting 17. And here also we can say there's 23 and 26, it is getting 49. So SPT value of the in the field, it is 49. Okay, first 17 it will not counted. Okay, so here also, if also you can see that it is depend on the soil strata SPT value. Okay, it will be increase or it will be decrease at 53, then also is 47. So it can it is depend on the soil strata, the soil medium. And at per site the penetration of the depth mm, 0.4 मतलब 4 is meter, मतलब 450 of the sampler depth. So here this is the type of one type of record of the SPT test. Okay, after collecting the sample as a disturbed or undisturbed, the sample will tested into the laboratory, uh, as all sample will package as per depth of 1